Pie charts. Statisticians loathe them. They hate pie charts. I kind of like them. They can be very informative. These are just fun. So things I learned from watching CSI. I like the red and the orange ones. Those are fun. Kill someone with anything. Yeah, I like that. Direction of blood splatter. This is a fun math one actually. Direction of blood splattered from. It's fun. It's vectors. Oh, yeah. Blunt force trauma is vectors. Totally cool. Remember the movie that showed numbers? Remember that one back in the day? There's a really cool probability in that course. Really, same kind of thing. Think out of the box, faced with problems, i.e. Rules 243 course. Good stuff. Here's some more good ones. Love that one. One of my favorites. Child of the 80s, definitely love that one. Are you guys old enough to remember when a car alarm actually meant like, holy crap, somebody's car is being stolen?
Yes.
Yeah. Like, I never think that anymore. I'm like, oh God, shut that thing off.
Yeah.
It's become like this background noise that we're accustomed to hearing because they malfunction so frequently. It's kind of like somebody's cell phone going off in it. Like I was at Taekwondo practice with Max last night. 3 parent cell phones went off during, and it was funny because it used to be 10 years ago when that would happen, I'd get pissed. But now, it goes off, and it has to keep going off in order for it to register with my brain that it's going off. Like, I'm watching him intently, like, doing his Taekwondo. It's adorable, 6-year-old doing Taekwondo. And eventually I'm like, oh God, your phone's going off. But he's like, oh God, you're right. Like, it's ringing for like 10, 15, 20 seconds. She doesn't realize it, I don't realize it. Master Graf is like focused in Zen. and finally, it's just like you become accustomed to it. Or in this case, you become accustomed to not wanting to hear it. So, anyway, kind of fun. I'm sure you've noticed this before?
Yes.
Yes, I'm sure you've noticed it before. More.
Very unorganized wallets.
Yes, exactly. Can you pay with cash? I'm like, please, don't stress me anymore than I already am. So anyway, pie charts are fun. Statisticians don't like them. Statisticians don't like pie charts. And it's great for qualitative data. It's great for qualitative data, although we will get away from qualitative data today. Does anybody know what the criticism of pie charts is? Like, for example, I mean, they're silly data sets, of course, but what the criticisms are of pie charts? Not the data is just ridiculous, but just the point of a...
Well,
go ahead, John.
Sometimes based on the way that you're looking or the vision is, I mean, it can be skewed, the data can be skewed on the size of the eye.
Yeah. A couple of you guys actually on your last exam submitted a pie chart that was done incorrectly on one of the news networks. I forget which data it was, but you had, I forget who submitted this, it was a great one. It was a pie chart. It was like 60%, 50%, 30%, 20%, 10%. And you were like, that adds up to like 516%. It's supposed to add up to 100%. Don't forget that. That's going to come back and revisit us for the next 4 weeks together. So it's supposed to add up to 100%, but this pie chart that you guys found brilliantly was not added up to 100. So, and the other problem is too, when you start tilting them and doing things like this, it becomes, what is that? With any level of precision. I don't know. I mean, it's more than 50%, I think. Right? Is it 60?
Yeah.
Is it 70? Is it 65? If you need any kind of precision, it gets very hard to pull the precision from an image like this. So that is why pie charts get frowned upon by statisticians. They would rather use bar charts like this, which is as best I could do to approximate that data. I didn't make that pie chart, so best I could to approximate it. It's also a great way to ruin a perfectly good joke. But actually, it makes the 11 items or more thing jump out a lot more by doing it this way, doesn't it? Yeah. Makes the little 10 items or less kind of fall down at the bottom there. You could make it Pareto if you wanted to. That would have probably driven the point home even more. Remember Pareto diagram? Put the tallest one first.
Yeah.
Put the next tallest one second. Third, fourth, and then fifth at the very end. There's carrot. Remember carrot from the first day of class? Carrot, broccoli, think of a vegetable. I know it seems like it was a year and a half ago. It was like 5 weeks ago. So anyway, what I want to do is I want to get into this idea of relative frequency today. Relative frequency is the same as probability. Now, while we're talking about this, what I want to ask you guys to do, we won't have to do both today, I don't think. Grab 2 dice. I'm going to hand, this is a bin of dice, kind of like we did in 105 last term. Grab 2 different color dice. Grab 2 different colors. You'll see why momentarily. And just pass that around. This is a bit of a repeat from 105 here, and I apologize. But we're going to start tying in your ideas from your project with what we've been doing in class. Averaging, standard deviation, but also probability. I talked to some students after class on Tuesday, and the concern was that the projects were deviating too far from what we were doing in class. It was a brilliant observation, actually, totally brilliant observation. And there's a reason for that. The reason I do that is because I like seeding that idea in your mind, in the back of your mind, and then at the right time, i.e. halfway through the course, we bring it to the forefront and link it up with what we're doing right now. So that's where we're going to start right now.